Best way to record is just to have it on there and forget about it. So today we're going to talk about lines. And to start with, what do we need to talk about? Slope between 2 points. And we need to talk about what the different forms of a line. I think I already mentioned this, didn't I, in class? Let's see. Slope-intercept. I think your book calls this standard. It's also known as a general form. And then there's the point slope form. I probably get the most mileage myself out of the point slope. I think it's the best tool out there. A lot of you guys did probably way too much y equal mx plus b in high school without really understanding it. And without, master the point slope. You want to be able to think of things as, you want to think of lines as starting with the function x, and then the slope makes that function tilt steeper or less steep or to the right or whatever, and then just think of shifting that thing left and right, up and down. So steepen it, move it up and down, left and right. That's how I want you to think of it. And you will be before the end of chapter 1, I hope. Form. 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 So what's the slope of a line between 2 points? And let's give them names. What's the phrase? Slope equals what? Sun. Oh, the last thing you said was run, so that was the first thing I wrote. Funny how the mind works. Rise over run. Hey, that's the change in the y values divided by the change in the x values. And so y2 minus y1. And I'm going to make the arrow point in the direction that that is. y2 minus y1 points from the old one to the new one. I think we did this, a little bit of this picture, same picture for Pythagoras, didn't we? x2 minus x1, think of that as that arrow pointing from x1, y1 to x1, x2, y2. Okay. So an example, quick example. I don't know, 2, 3, minus 5, minus 7. The one thing, Michelle, about doing these videos is I might go quicker to keep the time down, and then you can always pause it and run it back. So when I go into hyperspeed and you're no longer able to understand me at all, you can put the video on and slow it down to like 1/4 speed, and it'll sound like normal human speech. Yeah, no problem. So I'm gonna. If you're not really strong on this, you want to write this down every time. After the first 5,000 of these, I stopped writing the x1, y1, x2, y2. But it's nice to label them there, because then you can say slope equals m equals y2 minus y1, and until you're like totally solid on this and don't ever have to look it up, write that formula down every time. That's your drill. Don't sit there trying to one sitting memorize it. Just when you do your homework, write your homework like you're in training for a test, because that's exactly what you were doing. Okay, you're not doing the homework to get points from me. You're doing the homework to train yourself and build bigger guns. Right? Yep. So minus 7 minus a minus 5 divided by minus 5 minus... Wait a minute. I can do this perfectly without you guys watching. Minus 7 minus 3 is the y1. Very good. Minus 5 minus x1. x2 minus x1. Okay. Minus 10 over minus 7 equals 10 sevenths. Equation of the line. equational line through them. Okay. I use this. This is a point slope form. Most textbooks put the y1 on the left-hand side. That's stupid. You can actually use this function the way it's written. You can just start using it right away. Slope is 10/7 times the quantity x minus my x1 is 2 and my y1 is 3. I could just as easily use those other points, the other point rather. That's the same line. If your teacher asks for an equation, stop right there, or store. Stop right there. Okay, that's an equation of the line. Okay. And the thing I was saying earlier, just this is a little preview of the future. I probably shouldn't include it here, so of course I will. You want to think of these things in terms of the line y equal x. Know everything there is to know about the line y equal x. And then, what about y equal 10/7 x? Well, that's just that same line, steeper. Right? And what you're going to learn soon, that's that same line moved to the right, too. You delayed everything by 2. Everything's happening to it 2 units later, 2 minutes later, 2 hours later than it happened to the other one. So replacing x by an x minus 2 is a delay. It shifts things to the right. You're later on your timeline. You got up 2 hours later. Okay? And then what about the y equal 10/7 times the quantity x minus 2 plus 3? Well, that's that same line moved up 3. You see what I'm saying? So this point right here at 2, 3, actually started at 0, 0. And multiplying by 10/7 made everything steeper, shifting to the right by the x minus 2, and then moving up with a 3. This is coming soon to a math class near you. If you can see lines this way, which is alien to everything you've seen about lines in your past, it's foreign, but that's what fits into being able to graph functions like, I don't know. You can do the same thing to an x squared function to get that graph. Sweet. Exciting. And don't panic because it's not coming up. This was supposed to be a 10-minute talk on lines. So if I asked you for, and the book does on the 1.3 homework, if I asked you for the slope-intercept form, that's y equal mx plus b. And one thing I like about the way I do point slope is that all I have to do is expand things. 10/7 times x minus 10 times 2 is 20/7 plus, how many sevenths is 3? 3 times 7 is 21. So that's 21/7. Now, can you add 21 to 20? I can. What is it? This many. Right? Standard form has all coefficients in what's he doing to us? What does that symbol mean? Excuse me? What does the z mean? Well, you can't forget if you only heard it from me because I never said it to you yet. It's the set of integers. So that's just a very compact way of saying are in the integers. Here's your standard form. Whoops. ax plus by equals c, where a, b, and c are all integers. Like counting numbers or negative counting numbers or 0. Yeah, and that's just a really are in the integers. And apparently in the is one word, and that's okay. That's what that means. Okay? So I've got this the equation I had above, and I don't know why. There, I needed to get rid of that thing at the bottom of the screen. Multiply everything inside there by 7. 7y equals 7 over 1 times 10 sevenths. 10 sevenths x plus 7 over 1 times 1 seventh. So 7y equals 70x. No. 10x. The 7's cancel. Plus 1. And those are just implication arrows. It makes this a nice run-on sentence. The first thing implies the second thing implies the following. Minus 10x plus 7y equals 1. And so there's my ax plus by equals c with all integer coefficients. Whole numbers and negative whole numbers or 0. Okay? And all I have to do is just clear the fraction out. The book will typically do this. 10x minus 7y equals negative 1. For style purposes, I'd say just stop when you get there. It's just prettier to have a positive 10x. The last thing to prepare you for homework, parallel lines have same slope, have same slope. The slope of the parallel line equals the slope of the original line. Perpendicular lines apostrophe their slopes are negative reciprocals. The slope of the perpendicular line is minus 1 over the slope of the original line. So a standard question for this would be parallel to y equals, what was it? 10 sevenths x plus 1 seventh. Through the point pi 17. Done. Perpendicular through 17 pi. Y equals minus 7/10. See? Negative and flip it. X minus 17 plus pi. Done!